Hey everybody, and welcome to the first video on lists. So this is a video about how you store lists of information. So how do you store lists of numbers, lists of words, lists of characters, whatever. So in C++, a list is called a vector. So this is a video about vectors. And the word vector is supposed to be mathematically suggestive. So if you have had linear algebra, a vector is more or less just a list of numbers that you write vertically, right? So anyway, in this video, I will show you how to create vectors, how to create lists. I will show you how you set them up, how you put things inside of them, and then I will show you various other things that you can do with them. So I will show you all of the syntax involved in creating lists, and then I'll show you a few things you can do with lists. Now, before we get started, I should say that vectors or lists, whichever word you want to use, but vectors are quite challenging to work with. They take quite a bit of getting used to, probably more so than loops, more so than if statements, certainly. Okay, so vectors can be extremely frustrating to use if you're not used to them. So just like anything else in this course that you may or may not have found frustrating, you just have to give yourself time to get used to things. You just have to write enough code that you understand what's going on. So be prepared to be confused and frustrated by vectors, but we've built enough time into the course and you will do enough coding with them that you should be comfortable with them in a week or two. So before I show you the syntax, let me just motivate why you might want such a thing. So suppose you want to write a hangman program, and one feature that you want is for the user to see all of the letters that he or she has already guessed. If you want that feature as part of your code, you need a way to store all of these letters. You need something in the code that lets you just add a letter to a list, so that when the user says, I'm guessing an E right now, you can put that E into a list of letters you are creating, and that list is designed to show the user what he or she has already guessed. Here is another example. Suppose you run a bookstore and you want to keep track of the prices of all of your books. You could, I suppose, have a variable for each book that would look like this. You might use doubles because prices can have decimals in them, right? So let's say you have, I don't know, 200,000 books at your store. I suppose you could create 200,000 different variables, one for each book. That is prohibitively difficult. Okay, so if you want to keep track of thousands of different pieces of information, it is just not practical to create thousands of different variables one at a time like this. So without a way of just creating a list of prices, okay, so without a way of just creating a list to store all of this for you, programming in the real world would be completely impossible. Okay, so that's why we need lists. So C++ gives you the option of storing a list of data in a single variable, essentially. So your list itself, your vector itself, acts like sort of a single variable, and that single variable has all of these individual components inside of it. So rather than declaring 200,000 different book price variables, you would just create a single variable that is a list of prices. Okay, and that might not sound like much of a difference, but it's a humongous difference. It means that you can actually do programming in the real world. I should say that there are two kinds of lists in C++. They're both vectors and arrays. So if you've done MATLAB or something before, I think MATLAB uses the word array. I could be wrong about that. But anyway, vectors are sort of the newer, sexier kind of list, and arrays are the old sort of like fuddy-duddy kind of lists, right? Like, hey, the 1980s called and they want their lists back kind of thing. The reason that we will use vectors and not arrays is because arrays can never change size. So if you have a list of 10 things, it's going to stay a list of 10 things. Even if you want to get rid of some things or add some things to it. You can't do that with an array. And that is extremely obnoxious. Because again, imagine you're writing a hangman program where every time the user guesses something, you want to add an entry to your list. You can't do that with an array, but you can with a vector. So that is why we will be using vectors. So I mention this just because these are still in use in practice quite a bit through like historical momentum, right? But so if you hear that word, it means basically the same thing as a vector, but vectors can do more. So that's why we will stick just with those and we will ignore these. Yeah, so if you hear the word array, array is also just a list. So it's just a vector for our purposes. Now, if you want to use a vector, the first thing you must do is include the vector library like this. So it's kind of like with strings. If you want to do anything with strings, you have to do #include string here. If you want to use vectors, you must include the vector library. So here is how you create a list. First, you say, hey, I'm creating a list. Then you tell it what kind of list it is. So if you want a list of whole numbers, you would put int right here. If you want a list of words, then I suppose you would put string right here. If you want a list of true-false values, you would put bool right there. Okay? So the first thing you say is, hey C++, I am creating a list. The second thing you do is tell it what kind of list it is, integer, float, whatever. Then you tell it a name. So you have to name your list. And then you can tell it how many entries will be in there. So just for example, if I want, and let me put my vector library up here. If I want to create a list of 5 whole numbers, I would do it like this. Vector, int. So I've told the computer now, please create a list for me. That list will consist of integers. And then you have to give it a name. And if you know you're going to have 5 numbers, you can put a 5 there. So there you go. This is now, there's nothing in there yet. There are 5 entries waiting to be filled, right? I haven't told the computer, like, I want the first entry to be 7. I haven't said anything like that yet, but you've now created a list with 5 entries whose entries you can now fill if you want to. So I'll show you how to do that in a second. Let me now just mention a couple of things. Oh yeah, so 10 integers would look like this. The name here is irrelevant. You can name it whatever you want. But this first word vector must always be the same. I should mention that when you declare a vector, you don't have to give it a size. So if you leave that size off of there, just leave the parentheses and the number off, it will just create an empty list. And then later, since vectors can change size, you can add stuff to it if you want later. And I will show you how to do that. Okay, so the first thing we'll talk about is how do you access individual entries inside of a list? And you do it using the bracket notation that you saw from strings. So if your vector is called myvec, if that is your list, and you want to access the entry at position 2, position 3, whatever, this is how you do it. Myvec, square bracket, 2, 3, whatever. Okay, now this is really obnoxious. The students hate this. As before, with strings, C++ starts counting at 0. So the first entry of a list is not in position 1. Sorry, okay? It's really annoying to most students, okay? The first entry is at position 0, just like the first character in a string is at position 0. The second entry is at position 1, and so on. So if you type myvec bracket 1 right there, you are not accessing the first entry in your list, you are accessing the second entry. If you want to access the first entry, you must put a 0 right here. Yeah, so hopefully this reminds you of strings. A string actually is a vector. A string is essentially a list of characters. So a string is a vector of characters. So now let me come back over here, and let me just say, like, maybe the 5 numbers I'm interested in are Let's start with like 7, okay? So again, what does this mean? This means my list at position 0, the entry at position 0. So what I'm telling this code is that I want 7 to be my first entry. And so now if I ask the code, like, hey, what do you think the first entry in my list is? Let's just see what it prints. I mean, it's no shock here. It prints 7 because I just told it to put 7 in there in the first entry. And then the second entry, obnoxiously enough, is at position 1, 13. So I can just fill in my vector like this if I want to. So I have 5 positions. So let me just give it 5 different numbers. 4 equals 10. Okay, so I have now created a list with 5 entries in it. The entries are 7, 13, 15, -5, and 10. The positions run from 0 up to 4. So at position 0 is 7. At position 1 is 13, etc. Okay. So let me now just move on and show you things you can do with vectors. I've shown you how you can put things in there if you want to. The first function that comes with vectors is the size function. It tells you how many entries are in your list. This is in contrast to strings, where the analogous function was length. Okay, so it's sort of unfortunate that it's not the same word. So remember, with a string, if you want to know the number of characters in it, you use length. With vectors, if you want to know the number of entries in it, you have to use size. So let me just come back here and let's ask the computer, hey computer, what do you think the size of my list is? And of course it should print 5, right? Because there are 5 entries in there. So notice, just like with strings, your size is actually 1 more than your final position, because C++ starts counting at 0. So this is always true. The size of a vector is always +1 of the final position, just like with a string. Okay. Yeah, so if you ever want to print all of the entries of a vector, what you have to do is just print the first entry, print the second entry, print the third entry, and so on, all the way until you are done. And remember, since size is 1 more than the last entry, you stop right before you hit size. That's why there's a less than there. So this for loop right here will always just print all of the entries of a vector. So let me just put that in here. So for, please start at position 0 and stop right before you get to the size. So in this case, my list.size, I++, and I can just see out my list at the current I position and put a new line in between just so it looks nice, and let's run it. Notice that it printed this list, right? So again, when I is 0, it prints the 0th entry. When I is 1, it prints the 1th entry. Whoops, etc. So it just cycles through. Now, one question you might have is, why don't I just put a 5 right there? Because I already knew the thing had size 5, right? So if I run this, notice it does the same thing, of course, because size is 5. The reason that I always do this is because, again, vectors can change size in the code. And so I don't want to have to keep track of what the size is all the time. So like later in the code, I might choose to delete that. And now I would have size 4. But if I have size 4 and I put a 5 right there, it's different, So if you don't want to have to keep track yourself of the size of vectors, you don't want to actually put the number here yourself, just always put mylist.size, myvec.size, whatever, because you're always going to go up to 1 less than the size, no matter what the size happens to be. So anyway, if you ever just want to see what is inside of a vector, this for loop will always do that for you. So when you are troubleshooting code and a vector is not doing what you want it to do, you can always just put this in your code when you're troubleshooting and just ask the computer like, hey, what's in there right now, and it will tell you using that for loop. Okay, so now let's actually use a vector to do something. Let's save the first 200 even numbers into a vector. So let's create a vector with 200 entries so that those 200 entries are the first 200 even numbers. So notice I could do something like this. I could say, okay, so I know I have 200 entries, so I'll put a 200 there. And I know the first entry is supposed to be 2. I know the next entry is supposed to be 4, 6, 8, 10. So I could do this. And I'm already getting tired typing this, right? You see this is not efficient, right? So I could literally save all of the entries in myself, but that is not efficient. I mean, imagine if I put 20,000 right there, right? You would have to sit there and type 20,000 lines of code. So rather than doing that, let's just use a for loop, okay? So we know already how to create the first 200 even numbers because you all have done homework on this. So let me just take this out. And now, what do I want to be at position I? So what do I want to be at position 0? At position 0, I want a 2. And then at position 1, I want a 4, etc. So if you want that to happen, you can just use a formula like this. This is very similar to the homework you have done already, where you printed even numbers to the screen or something. So what will happen on the first pass-through? When I is 0, 2 times 0 plus 2 is 2. So at position 0, I have 2. When I is 1, I have 2 times 1 plus 2 is 4. That goes at position 1. When I is 2, I have 2 times 2 plus 2 is 6, etc. So let's just check that this does what we want by asking the computer to print my list.size, the vector after it's been created. So we'll see out those guys. So we'll see if it worked or not. Yeah, sure did. Right? Started at 2, and it will print all the way to 400. So that means that these 200 individual numbers have been saved into this list. Okay, so without too much work here, on some level, I have 200 separate variables, right? I have a variable at position 1 that now has a 2 in it, a variable at position, what did I say? At position 0 has a 2, a variable at position 1 that has a 4, a variable at position 2 that has a 6, etc. But notice I've condensed all 200 variables into a single thing called a list, right? So that's what makes vectors so nice. You just condense all of those individual variables into a list. So each variable has its own spot in the list. Okay, so before leaving this example, I should say that one thing that students get really frustrated with when you are not used to vectors, it's really easy to forget what's keeping track of what. So every single list has an entry at a spot, and you have the spot itself. Okay, so you have position 0, and at position 0, you have a 7 or something. In this case, we have a 2. And you have like position 6, but at position 6 is a 13 or whatever. Okay, so until you are comfortable with lists, it's very easy to lose track of like, am I talking about where I am in the list or what entry is at that spot in the list? Okay, so am I talking about position or the entry at that position? It's very easy to get these things confused. So when you're doing this bracket thing, this is the entry at position I. This whole thing is an entry inside of the list. The I is the position where you are inside of the list. So until you are comfortable with vectors, be prepared to be annoyed by that sort of thing. Okay, so here is just the loop I set up. So I want to close this video by showing you how you can either like add things to a vector or take things away from a vector. If you want to add something to a vector, so again, imagine you've kept track of the letters B, C, and D because those are 3 letters that a user has guessed, and now they guess T. So you want to now add T to that list of numbers, or sorry, to that list of letters you already have. You can use this function called the pushback function. What that does is it will take whatever you put inside the parentheses and it will create a new position at the end of your list, and this pushback function will put A there. So let me come back here, and just so let's just pare everything down here. So let's do like 4 things here. Okay, so now I'm just going to do the first 4 even numbers. So let's just check this code does that. Okay, so right, all I did was change the 200 to a 4 because I only have 4 entries now. And look, there's my vector. Okay, suppose you want to add 10 to the end of that yourself. You say to yourself, I have 4 things there. I just want to add the number 10 to the end of that. You can do it just like this. You can do my list dot push underscore back 10. So you will literally throw a 10 onto the end of that. Okay, so right here is where I print the list the first time. Let me now print the list again after doing this line of code. And let me separate those 2 loops with a new line. Okay, so when I run this, notice what happened. The first time I print the list, I get that, 2468. But then, after I do that printing, I throw 10 onto the end. And notice now I get 246810. 10 is now at the end of that code, or at the end of that list. And so again, that's why I keep the size thing here, because I don't want to have to keep track of how big the thing is every time. Right? So I suppose I could put 4 there and a 5 there. But as I keep messing with this list, I don't want to have to keep keeping track of all these things. Right? So that still works, okay? But again, in a bigger program where you keep messing with lists, you don't want to have to do that. Okay, so here's how you can add something to the end of a vector to make your vector grow. If you want to kick things off the end of a vector, you use the pop back function. So that will kick off the very last entry of a vector. So let me just show you that. Okay, so I added 10 to the list. Now, after I do that, let me do this. My list dot pop back. And now let me print the original, let me print the list again. So again, I don't want to have to keep track of the size. So let me do my list dot size there. Okay. So it starts by printing 2468. That's happening right here at the very beginning. Then I added 10 to my list and I printed the resulting list. That resulting list is right here, 246810. After that, I used the popback function. So what that was supposed to do was kick the last entry off. And notice, when I print again, I have 2468. So it worked. And of course, you can use these functions more than once if you want to. So like, if you want to kick off the final 2 entries, you can do that. Just use the popback function twice in succession. So 2468 is what I start with. I then put a 10 at the end of it. Oh, but then I pop back twice, which will delete the final 2 entries, and now I'm just left with a 246. Okay, so that is all the material for this video. So you should now be able to do a few things. You should understand what a vector is. You should be able to create one on your own and put entries in there on your own. And you should be able to access individual entries on your own. And you should be able to change the size of a vector by using these functions here, a pushback and a popback. So we are certainly not done with the tools we need for vectors, but this is a good enough start for now.